Good afternoon. I'm so excited everybody is joining us this afternoon. We have almost everybody logged in already. You guys are really quick today. So I'd like to invite you, first of all, to introduce yourselves in the chat box. Just your name and where you are logging in from would be fantastic. As well, if you could tell us how you heard about the webinar. We're going to get going in just a second. I also have up on the screen some quick guidelines for everybody. As a reminder, we cannot see you through your camera. We cannot hear you. You're going to be muted for the whole time. So the way to put questions for us, for our speaker today, is through the Q&A tab on your webinar. So if you could do that, use the Q&A box. Or if you're having technical difficulties or have just a comment about our presentation today and our presenter, you can put those comments into the chat box as well. We'll get going in just a second. And it looks like most of you have voted in the poll already. I'm going to leave that open another 30 seconds or so. But while I do that, I'm going to take a quick opportunity to welcome you. I'm really happy that everyone's here today. Today is our fourth 4-H QuaranTEEN Virtual Science Café. I'm Laura Wilson, 4-H science professional. I'm really glad you could join us. 4-H is a community for all kids with programs that suit a variety of backgrounds, interests, budgets, schedules, from in-school, after-school, clubs and camps. Our positive youth development programs are available in your local community. We welcome every kid who wants to join us and have fun. 4-H is the youth development program of the University of Maine, brought to you by University of Maine Cooperative Extension. Here with our Maine 4-H team today, we have Dr. Vanessa Klein, Alice Philbrick are monitoring the chat, and Jesse Brainerd is here hosting our Q&A. You can use that Q&A tab to ask questions of our presenter today, and Jesse will make sure that he gets those questions and has a chance to answer them for you. We are going to keep the session simple. Our guest will share some of his cool science and tell about himself and his pathway to working here at the University of Maine. And then we'll have plenty of time for you to ask even more questions. A quick note again about the chat. We want to see your reactions to what our guest presents. Please keep on topic, keep the language clean and appropriate so we can keep that feature on. And if you have any questions about any terms our guest uses today, our people monitoring the chat, that would be Vanessa Klein and Alice Philbrick, will be happy to define terms and help you out there. So it's my absolute pleasure today to welcome Dr. Colt Knight to our virtual QuaranTEEN Science Cafe. Dr. Knight, can you introduce yourself and the cool stuff you're doing at the University of Maine?
I can, and I will. So I'm just going to share my screen so that not everyone has to look at my face this entire time. All right, does that seem to be popping up?
Looks good to me.
Are you seeing my PowerPoint now or my presenter view?
We see your PowerPoint and not your presenter view.
Okay, excellent. I can get started.
So we see what you want us to see.
Yeah, so just to introduce myself here, my name is Colt Knight. I'm a professor here at the University of Maine. I'm the state livestock specialist for Cooperative Extension. And if you're not real sure what that is, I'm going to go into that here in a little bit. Just about myself, I grew up in West Virginia as a third-generation coal mining family. When I was a kid, my daddy always said, son, you need to go to school so that you can work with your mind and not your hands, and you won't, have to work outside all the time and constantly hurt yourself, like my dad did and my grandfather did. So as soon as I graduated high school, the first thing I did was go to work in a coal mine. If you've ever worked in a coal mine, you understand that coal mine is not the place to be. So not too long after working in the coal mines, I decided, hey, my daddy's words of wisdom were quite prolific, and I needed to follow that advice. So I actually left the coal mines and I went to school until they wouldn't let me go to school any longer. So I ended up with a PhD in animal science from the University of Arizona, and I still wasn't done. I went on and did a postdoc working at New Mexico State University after that. But as you can see here from my educational background, I went to school all over the country. I started out living in West Virginia, then I went to Kentucky, and then I went to Texas, and then to Arizona, and then New Mexico, and then I ended up here in Maine. And so what I do here in Maine, my title, of course, is Assistant Extension Professor and State Livestock Specialist. So what that really means is that I help teach classes. I teach the Introductory to Animal Science class here on campus. We usually have about 100, 110 students taking that class. I conduct applied research. And when I say applied research, what I mean is we do research that directly correlates to like on-farm activities. It's not just, test tube type stuff or wet chemistry stuff done in the lab. We're actually working with live animals out on the farm. And then something else that I started since I've been here at the University of Maine was the grazing behavior lab. It's very unique. We're one of the few campuses in the entire world that have a grazing behavior lab. And so I run that here. And what we do there is we actually manufacture livestock GPS tracking collars. And then we use those for applied research throughout the world. We have projects going on in Australia, half of the states in the United States, Canada, Italy, Kazakhstan, Mongolia, just to name a few. And that's kind of the professor side of my job title. Now, the state livestock specialist side of my job title, that's directly correlated with extension. Extension is the third branch, if you will, of the university. The university's goals are teaching, and so we do that by having classes here on campus. Research, and we do that by conducting research either here on campus or applied research like what I'm involved with. But the third branch of the university that a lot of folks are not familiar with is actually outreach and service. And that's what extension is there for. So extension is there to bring the latest, most up-to-date scientific information to the general public, not just the students enrolled at the university. So I work directly with farmers, mostly livestock folks, and I help them work through problems that they may have with animal nutrition, reproduction, housing, animal handling, anything that has to do with raising animals on a farm. I help folks with that. My number one specialty is beef cattle. That's what my degree is in beef cattle. But I work a lot with small ruminants. And when I say small ruminants, I'm referring to goats and sheep. We do a lot with pigs, a lot with poultry. I do a little bit with horses, not a ton. But the sixth thing that's on this screen here is meat. We do not have a meat science program at the University of Maine any longer, which is a real shame because, most livestock is raised to enter the protein chain of the human diet. Other byproducts like leather or fiber from sheep and goats that produce cashmere or wool are all important too. But there seems to be a growing disconnect on where our food comes from. And so I work really heavily with producers to connect their end product, which is the meat from the livestock they raise, to their consumers so that everyone is on the same page and knows where their good, wholesome protein's coming from and how to utilize it properly. Here's just a quick picture of my grazing behavior lab. That's actually a buffalo leather hide that was tanned here in Maine. On the table there. Then there's some sheep and goat GPS collars. When I get done with this PowerPoint presentation, I'm going to switch over to my cell phone and give everyone a tour of the lab here. This is some of the research that I've been helping with here lately. This is actually the San Luis Obispo Valley on the coast of California at Cal Poly University. We put GPS collars on these mature cows because we want to see not only how the cows use that landscape there and how they interact with the mountains and the valleys and the fog and everything that roll in, but we want to know what the generational data is on those animals. You know, when they have babies, do those babies have the same grazing characteristics of their parents? And if they do, can we predict that behavior with a genetic test, like a blood sample or a hair sample? If we can do that, that saves us actual generations worth of just visual observations. So if we can just go to the sale and buy calves based on their genetic potential, then we can select animals that are bred to live in a specific environment. And if we can do that, we can increase our efficiency and make sure that we're using both the animals and the landscape to the utmost of their potential. This slide has a couple pictures on it. Over there on the left is actually the Witter Center. That's the teaching farm here on campus. This was actually a pasture chicken project that we conducted a year or two ago. We wanted to see what is the best breed of chicken to raise out on pasture for meat here in Maine. And this study has never been done before in this environment. So we were actually able to raise 6 different breeds of chickens out on pasture. And then once we collected all that information, we were able to tell everyone, hey, look, these chickens are best for this environment. It was really fun. Now, the grazing behavior aspect of that was we actually monitored forage utilization of all these chickens. And when I say forage utilization, that means how much grass do those animals eat, trample, peck, scratch, defecate on, you know, how much of the grass do they remove from the pasture? And then we're able to estimate what percentage of their diet is actually grass. So with chickens, it turns out that that's actually a really low percentage of their diet. It's only about 3.5% of their diet. So a lot of people think just because we raise chickens outside that we don't have to feed them as much because they're going to supplement their diet with hay or grass. And that's simply just not true. They actually eat more feed outside on pasture because they expend more energy walking around and regulating their body temperature. In a similar study, we actually just started a pig program here at the university. We went out and got some of the best pigs in Maine, and we're raising them out on pasture so that we can help producers here in Maine, you know, answer all the questions about how to raise pigs on pasture. For the last 50, 75 years, almost all the research with pigs has been done in large-scale confinement operations. So we've lost that generational knowledge of how to raise pigs in small batches outside. So we're kind of recapturing that knowledge now, and we're in the process of that project at the moment. And if you happen to attend the University of Maine and join the animal science program, you can help take care of the pigs through the Maine Animal Club and work with farrowing, and that means when the pigs give birth and raising up the pigs and following them all the way through to selling the meat in the very end. And then one of the the other aspects of my job that I talked about earlier is I actually get to go out and meet farmers, look at their animals, give them advice, help them work through problems. If we find outstanding producers, we like to showcase those to other farmers so that everyone can be part of the good things going on. And then in my Meet Science program, I was having a hard time with folks understanding just how important it is to connect livestock producer with the end product and the consumer. And to do that, I started doing barbecue demos, because who doesn't like barbecue? There, that picture on the right is actually some pork ribs that I smoked for about 6 hours and got them all cut up and ready to eat for everyone. Everyone really appreciates the barbecue demonstrations. I know I used to give educational seminars when I first came to Maine, and 3 or 4 people would show up, and then I started providing barbecue, and now we get 10, 20, 30, 40 people showing up. So everyone likes some good old-fashioned Southern style barbecue. And that's myself. And I have this spot here. I'd like to learn more about you. Does anyone come from a livestock background? And if so, was it chickens, pigs, cattle, sheep, and goats?
We don't have any questions yet, but just a reminder, if anybody has any questions for Colt, just type them in the Q&A and I will ask him for you.
And almost everybody has voted, so I'm going to close the poll in about 10 more seconds and I'll share the results with everyone.
Awesome. So the next section that we'll be talking about is a history of animal tracking, because what we really want to know is, what is that animal's behavior? Oh, it looks like the group is pretty well split here. About a third do not come from a livestock background. 20% have chickens, and 7% have pigs, and 7% have cows, and 33% have sheep and goats or others. Very useful information. Well, just a brief history. This is mostly focusing on beef cattle. So this is an old cow, and that picture is actually from Texas. So in the past, if we wanted to know how an animal utilizes their environment, we had to just go out and look at them. And you know, here in Maine, that's not a big deal because pastures are small and the animals stay relatively close together. But out west or in Australia or parts of South America, you could have 20, 30, 40,000 animals or more on miles and miles of land, spread out so far that you can't even find them. So to actually see how they utilize those big landscapes was very difficult. So the first technology we had was just to go out and look at them, and we characterize their behavior on a small subset and kind of tried to apply that to the whole herd, and it didn't work really well, not in a large scale. And then one of my colleagues from Texas developed this thing called a grazing clock. So you see this cow wearing a halter, and it's got what it actually is, if you've ever seen a seismograph that detects earthquakes, or a lie detector with a little pin with the squiggly ink lines on it, that's what's inside that grazing clock. So every time that cow lowers her head, the pin makes a squiggly mark on a piece of paper with a timestamp on it. And so we didn't know where the animals were, but we knew when they had their heads up and down, and so that indicated that they were grazing. And so we knew how often they were grazing, which was really cool, but it didn't tell us where they were going or how they were interacting or anything. So the next big technology that came along was radio telemetry. And I think you've probably seen this technology on movies or on wildlife shows or something, where you put a radio collar on an animal or a radio tracking device on something, and then you walk around with an antenna, and as you get closer to that radio collar or subject, it starts beeping. And the closer you get, the louder it beeps. So there were people walking around out in the desert, out in the mountains with these antennas over their heads, just listening for beeps to see if we could find something. And then when we thought that we were relatively close to something, we just pull out a map, put an X on it, and say the animal was here. And, you know, that wasn't really specific enough to be useful for livestock, but it was pretty good at tracking wildlife. And even today, it's still used for wildlife because the battery lasts so much longer on these radio collars than it does a GPS collar, that we can put these on for years at a time. And then the early GPS, the early satellite stuff that we did was almost useless because the government was afraid that if people had their own GPS, that foreign governments could use it to spy on us. So the government limited the resolution of the GPS, and that means how close we could tell something was to something, to 5 kilometers, you know, so a couple miles. So we could only be as accurate as a couple miles. So the only thing that it was really useful for was tracking large migration patterns of animals like elk or something that migrate from Canada down through Colorado. We could get a broad spectrum view of things, but we couldn't really see exactly where the animals were or how they interacted. Now that all changed in May of 2000. The government lifted those restrictions on GPS. Now, the students on this Zoom webinar are not old enough to remember pre-GPS times, but the instructors and 4-H folks are. And I think if you'll recall, it was around this May 2000 that car GPSs started popping up everywhere. And then we could find where we were going without maps. Now today,
I have a quick question for you.
Yes.
And now I have to, how does this research that you're doing help us in everyday life, and what can this information be used for?
That's a great question. We're going to talk about that a little bit here in a minute. But what we're trying to do is match animals with their environment. So we look at behavior of animals and then decide which animals are better suited to live in a certain environment. And then we can select for those animals to live in that environment so that they use that environment more efficiently. So there's less wastage. So for a producer, that directly correlates to more profit because they spend less money in inputs feeding the animal, and the animal can live off the land, so to speak, instead of us having to bring corn to the animal. The animal can just live on the native grasslands or pastures or whatnot. The other thing that we want to do is to make sure that these animals are not adversely infecting things like endangered species. So we want to make sure that the animals are well suited to their environments, and the only way to tell that is to monitor the behavior. We want to make sure that they're not destroying their environment, and so we can do that by monitoring their behavior. And we want to make sure that they're not interfering with other species of animals like wildlife, especially endangered species. Now, we don't have a lot of that concern here in Maine, but especially like out west, the Endangered Species Act is actually used by folks that are anti-livestock grazing as a way to shut down farmers and ranchers. So they'll say, oh, well, there's an endangered frog on this ranch. You can't have any cows there because it's destroying that frog's environment. Well, the government needs proof that the livestock aren't interfering with that frog's environment so that they can continue to graze and utilize that rangelands. So that's done quite a bit there too. Another aspect of this is just being able to find your animals and know where they're at. On a very large pasture, you might not be able to find your cows. You know, out in Arizona, so to speak, when the pastures are 250,000 acres, the GPS will tell you where those animals are so you can find them easily. In the future, we'll all be able to have our animals linked up to our cell phones, and there are going to be sensors like these accelerometers that measure animal movement in 3 axes, so front, back, left, right, and forward and backward, and up and down. When they get sick or they're about to have a baby, their behavior changes. And then we can use these accelerometers and the GPS movements to predict when those animals are getting sick before we can detect it with the human eye, and we can predict when they're fixing to have a baby, and it'll send an alert to our cell phone. And then we can go out and treat that animal before it gets really sick, you know, or be able to catch it before it dies, or help that baby to make sure that it doesn't get eaten by coyotes or wolves or whatnot. The other thing that will also be able to tell us is, say, if the cows get outside of the fence, and the cell phone will send you a text message and say, hey, cow 347 is outside of the fence. Let's go find it before it gets too far away. So in the future, and I imagine in our lifetime, we will have applications on our cell phones that are linked to our livestock to tell us all these things. Does that answer the question?
I think so. We just had one more question come in. We're have someone wondering, where are cattle native to?
That is also a good question. There are 2 major types of cattle. That is Bos taurus. Those are cattle that come from Europe. And there are Bos indicus and zebu cattle that are native to like the Indian Peninsula and through Africa. Bos indicus and zebu cattle are Brahman cattle. If you're familiar with like the rodeo cows with the big humps on their back and the big dewlap under their neck, those are indicus cattle. They got big floppy ears. And then there's Bos taurus cattle, which are like our Angus and Herefords and Charolais and whatnot. Most cattle breeds that we have today were not roaming free in the wilds 10, 20,000 years ago. They have been genetically selected like dogs. So you're not going to see exactly what they looked like 20,000 years ago. If you're really curious to what beef cattle looked like 300 or 400 years ago, I would encourage you to Google Criollo cattle. That's spelled Criollo. Those were cattle brought over by the original conquistadors and Christopher Columbus. And those actually got loose and lived in an isolated mountainous region in Mexico. So they remained unchanged over that 300 or 400 years. So you can actually see what cattle would have looked like back before pre-colonial times. Those are pretty unique animals. So this slide here, I've kind of already explained this, but this was actually some research that's being conducted out west right now. What we're looking for are lazy cows. You know, which cows are willing to climb up tall mountains to find fresh grass? It turns out that some cows are lazy and they don't like to walk up hills and they just want to stay down in the flat land by the water tank. And so what we've done using GPS collars is find the lazy cows. And then we're going to try to develop a genetic test that tells us which cows are lazy and which cows are not lazy. And so that brings me to my second question, which is, how does GPS actually work? You know, I find that most folks, when you say GPS, they know it has something to do with satellites, but they are completely unaware of how GPS actually works. So we'll let this poll kind of play out, and then we'll go to the next slide and I'll explain how GPS actually works. Are there any other questions while we're waiting?
We are all set with questions right now, but if anybody has any, put them right in that Q&A box.
Most people have voted in the poll. I'm going to give it about 5 more seconds and then I will share it with you. And it looks like most people are right where I am. I know it has something to do with satellites, but that's about it, Colt.
And don't feel bad, because even among the scientific community, that's most people's understanding. So the way that satellites actually work is we have a network of satellites that orbit the Earth. And they are in what is called constellation orbit. So that means that the satellites are equally spaced around the Earth. And to get constellation orbit, we need at least 24 satellites. We actually have around 30 GPS satellites currently working above the Earth's atmosphere. So that's good. We've got a couple extra in case, space dirt or a comet or something or trash takes one out. We've got a few extra, but they float around the Earth equally spaced, so that no matter where you're at on the face of the planet, you have access to at least 4 satellites. Now, if you have 3 satellites, you can do what's called trilateration, which is triangulation, but in 3D. It'll tell you about where you're at on Earth, but it can't tell you what your elevation is. But if you have 4 satellites, you can tell exactly where you're at on Earth and tells you the elevation. Now, if you're wondering why we have such a thing as GPS, it was originally intended so that U.S. Navy ships could coordinate with the U.S. Army. So before we had GPS, it was very tough for the military to coordinate the Navy that was floating on the ocean. So there's no visual things to look at. You can't say, oh, I'm out here by the big elm tree just south of 4th Street. You can do that on land, but when you're out in the middle of the water, there's nothing, and it's pretty hard to convince the Army guys to look at constellations and navigate by the stars, especially in broad daylight. So that was a way for the Navy to directly coordinate with the land forces. And then so we would always know exactly where the Navy was and how we could deploy them and how we could get back and forth. So what happens over time is we start having more commercial airplanes that fly across the borders of different countries. We start having large shipping container ships, cargo ships, traveling the entire world. And so some of these cargo ships and airplanes were accidentally flying into enemy territory. And so in the 80s, Iran shot down a commercial airplane that accidentally crossed the Iranian border. And so President Ronald Reagan decided to start letting shipping companies and airplanes and things have access to GPS. But of course, we were still worried about, the Russians using GPS to spy on us. We kept the resolution pretty low, and only the commercial transportation folks and the cargo ships had access to the satellites aside from the military. Now, in the year 2000, we lifted all those restrictions, and now we have access to all these satellites, and we can use them to find where we're at on Earth. So that's how GPS works. Now, there are other similar systems that are based on satellites, like the Iridium system, that like cell phones and things work off of, where there's actually a gateway here on Earth that's connected to a satellite, to like a ground antenna. And so the cell phone contacts the ground antenna, and the ground antenna contacts the satellite. So there's a middleman in that procedure. So it's a little different. But there's less people using it, so it's not as cluttered. And satellites, the actual signal that is sent from the GPS unit to the satellite is actually a low frequency radio signal. So if you're wondering what kind of waves or signal it sends, it's actually a radio signal. So how did I get involved in all this stuff? You know, what was my background into all of this? Well, I told you I grew up in a coal mining family and decided to go back to school. My family owned a show horse stable. So I grew up breaking horses and raising chickens and goats and things on a small family farm. So when I went to school, I studied animal science. I thought I was going to be a veterinarian until I worked in a veterinary office. And I decided, hey, you know, this veterinary life isn't for me. But I loved all the research that was going on campus. And I decided, hey, that's the path I should follow, is to become a research scientist. And so that's what I did. You know, I got my animal science degree from the University of Kentucky. I went on to get a Master of Science degree from Texas, followed that up with a PhD at the University of Arizona. Now, while I was at the University of Arizona, we were trying to do some grazing behavior studies with cattle out on a 70,000 acre ranch. And everything that I was doing was just going wrong. You know, I tried to do the visual observation thing with all these cows. I would get up into the thick canyon areas with tall trees and scrub brush, and I'd follow those cows around for about 30 feet, and they'd walk over a hill and disappear, and I'd never see them again. Well, then I was like, well, we could put pedometers on these cows, because that's what, you know, at the time McDonald's was giving them away and pedometers were the big thing. And so I mounted pedometers on cows, and that worked really well for telling me how much activity the cows exerted, but it didn't tell me where they were going. So I looked into buying some GPS tracking collars to put on my research cows for my PhD research. Well, it turns out at that time, GPS tracking collars were about $2,500 a piece, and I needed at least 30 to get a good experiment going. Well, I didn't have the $70,000 or $80,000 to buy these collars. I came from a pretty mechanical background, and I did a lot of leather work and things as a kid. So I said, well, why can't I just build my own GPS collar? Because everything has a GPS in it nowadays. You know, my cell phone has it. They make dog collars with GPS, you know, and they don't cost $2,000, $3,000 a piece. So why can't I just build my own? Oh, I see two questions here. I'll answer those right after this.
Okay, I was gonna ask you, just let me know and I'll read them out so we have them for the recording.
Okay, great. And so I figured, well, why don't I just source the raw materials and build my own GPS collar? So that's exactly what I did. So this is my apartment in downtown Tucson. I removed the dining room table. I brought in a workbench, and I actually made the GPS collars. And this is what those early examples looked like. Now, if you want to read the questions, I can go ahead and answer those too.
Sure thing. I'm going to ask you both of them because they're obviously connected. The first is, how do you harvest the leather from a cow? And then how hard is it to do leather work?
Excellent questions. First, how do you harvest leather from an animal? And so when an animal goes in to be slaughtered for meat, they skin that animal. And so at that point, it's just animal skin with hair on it. To make it into leather, you have to do a process, what's called tanning. There are several different chemicals that you can use to tan leather. The most traditional is oak bark, and that's called vegetable tanned leather. So that's what saddles and things are made out of, is vegetable tanned leather. Or you can use a chromium salt to tan leather, and that's how you get soft garment leather or couch leather or upholstery leather. So there's two different types of basic leather tanning. There's the vegetable tanning, which is done with natural tannins, like in vegetable trees and things. And then the next one is with salts, chromium salts, and that's how you get your real soft leather. So what they do is they soak that raw skin in these tanning solutions, and then they have to scrape all the fat and hair off of it. But then when it dries out, it's real hard, and you couldn't use it. It would be like a mummified rat or something like dried spaghetti on the countertop. So you actually have to stretch it and warp it and move it and work it back and forth to make it soft again. So at the big tanneries, they'll put all these hides in a gigantic rotating drum, almost like a concrete truck. And so the chemicals are preserving it, and the actual actuation is breaking it all down, and they put it through large scrapers to scrape all the fat and extra hair and stuff off of it. And then they let it dry out, and then it's leather. So that's basically how leather is made. The second question is, how hard is it to do leather work? And that varies greatly. So basic leatherworking projects like making a bracelet for your wrist or a belt to wear around your waist is very simple. It requires very simple tools. Those are easy to do. And if you want to decorate those items, you can buy what's called stamps. It's a lot like a rubber stamp, except they're made out of metal. You get the leather wet, you put the stamp on it, and you hit it with a hammer, and it makes an impression. And that's the easiest way to decorate leather. If you want to get really intricate with leather, you can do what's called tooling the leather. So like when you look at cowboy saddles or Old West gun holsters and things like that have all that beautiful floral patterns and things on it. So you actually have to draw the pattern on the leather and then cut into it with a knife to break the surface. And then someone actually goes in with a little tool and a hammer, and they actually have to beat in every single one of those impressions. So that's more difficult. And as you get more involved in that kind of thing, it gets more difficult and the tools become more expensive. But if you just want to start out small doing leather work, you can look up Tandy Leather and buy inexpensive kits that come with basic tools and the basic leather you need. And it's real easy and it's a lot of fun. And then the further you get along, you can do more and more and bigger projects. It's a great thing. Maybe after all this coronavirus stuff breaks out, if the 4-H kids want me to host some leatherworking workshops, we can get that done.
Hey Cole, I'm gonna remember that you're on video now and we're recording this, so I think we'd be on board with that.
Yeah, it's a lot of fun doing that stuff. So if that answers that question, I'll get moving on to, did my homemade GPS collars work? So this is the teaching farm at the University of Arizona, and this purple line, I actually put that GPS collar around my own neck and walked around the teaching farm to see if it worked. And it did. I showed this picture to my advisor, and he gave me money to build my own GPS collars. I built them for $87 a piece instead of $2,000 or $3,000. And the next step was we put them on cows. Sorry, I'll go back and show you that picture. There's the picture of the teaching farm. And there's Grumpy Cow. Grumpy Cow was named Grumpy Cow by my friend Lauren over in England because every time we did a GPS study, she got randomly selected for a necklace. And this was the 3rd or 4th time she had a GPS collar put on. So she came out of the chute and just gave us the good old death stare. This is a picture of Grumpy Cow walking around in about a 30,000 acre pasture in Arizona. And you may think, what are these long straight lines here? And that's actually, we put the GPS collar on here. This was the headquarters of the ranch. The cow walked up through this canyon. This was where water was, so she stopped here and got a drink and hung out for a day or two. And then she walked up through the canyon, and this up here is a flat grassland, and she hung out up here. And then we took the collar off right here. And this is actually the GPS collar riding in the truck on the way back to the headquarters. So those long straight lines are just the 10-minute intervals between the GPS taking a signal. So that's what that's from. Okay, now with that, let's move on to the third question. And I covered a little bit of this earlier, so I think everyone should get most of this.
They're answering really quickly.
That's good. That's a good thing. That means they're not asleep or playing the PlayStation.
We're up to almost 80% voting. I'm going to give about 5 more seconds, and then we'll show you all the results.
Okay. Yeah, so all of the above is the correct answer here. So the first thing we want to know is how the animals interact with the landscape. And then how do we use that information so that we can better utilize the pasture? So I want you to think of a pasture that's 30% mountains, 20% briar patch, and then the other 50% is just beautiful grass. So if that pasture is 1,000 acres, and our cows are really lazy and they don't ever leave the grasslands, they're only going to utilize half of the pasture. But if we can find cows that aren't lazy, that are willing to go through the briars and they're willing to go through the mountains and the canyons and things, then we can utilize 100% of that pasture. And that just improves the efficiency for both the rancher, the animals, and the landscape. And then while they're doing that, we want to make sure that they're not damaging the landscape. So if you have a lot of animals around a riparian area, and a riparian area is a wetland or wet area in a pasture, so like a stream bank or a swamp or a lake or something would be considered a riparian area. If the animals are circling around that real heavily, they can erode the ground. You know, they can stamp out all the vegetation, and then when it rains or the wind blows, all that washes away and it just destroys the landscape. And then when that starts happening, we start getting gullies forming, you know, like the rain will wash big trenches into the ground. And then once that happens, it starts a snowball effect. You know, just a little ditch turns into a big gully, and then the dirt slides off of the hill, and it just destroys entire areas. So we want to prevent all of that from happening. And we want to make sure that the animals are all getting along with their neighbors, like endangered species and deer and turkey and whatnot. We don't want to impact negatively their environment. The fourth question here has to do with public lands. So who actually owns all the land out west or in the eastern United States? You know, like who owns land in the United States? This question is specifically who owns the land in the western United States. And the reason that I'm asking this question is because the eastern United States are drastically different than the western United States.
So we're up to about 75% of the people have voted. I'll leave it open another 10 seconds or so. And just to keep an eye on the time, Colt, we're at about 10 of 4 too.
Okay.
Here are your results.
All right. So in the eastern United States, the land was settled by people just saying, hey, this is my land. And we were here before the government existed. So that land is almost all private. So that means that citizens actually own the land in the eastern half of the United States. Now, in the western United States, those states were founded in the pioneer days. And so what happened was the government told people, hey, if you move west, we can give you land. So those first settlers settled in Missouri, Nebraska, Kansas, Iowa, Oklahoma, and those countries. So those are mostly private land states because the government actually gave those settlers land to live there. Now, as time progressed, more and more people moved west by themselves. And as they got enough people together, they said, hey, you know, we need laws and government and help. We would like to become a state. And to become a state, most of those territories would actually give up their land to the federal government. So to the United States government, as kind of a bargaining chip for becoming a state. So most of those western states are actually publicly owned. And when I say publicly owned, I mean that they're government controlled. They belong to us, the people, but they are government controlled, and that is federal lands and state lands. Most ranchers that live in the western United States don't actually own the land that they raise cattle on. It's actually, they lease the land from the government. So one of the reasons that we have to make sure that the cattle aren't destroying the environment and we're using that land the most efficiently is because it's not just their land, it's everyone's land. So we have to be sure that we are good stewards of both the environment and the cattle so that we have food in our food chain. Now, some folks say, well, why don't we just raise cattle on private land and not on our public lands? The fact is that cattle ranchers can take care of these landscapes half as cheap as what the government can. Okay, so it is a benefit to us, the taxpayers and the general public, to have these ranchers on these landscapes. I see we have a question. And
we do. We've been asked, Haley is asking, what is the best type of cattle for here in Maine?
That is a question that I get asked every single time that I give a beef cattle talk, and it's not an easy answer. So let me start off by saying that there is no one breed of cattle that is best suited to all environments, but there is as much variation within among the breeds as there is within the breeds. And what I'm trying to say here is that there are different breeds of cattle that in general are better suited to different types of environments. So if we were to draw a line here about North Carolina and run it all the way across the United States, cattle south of that line, you start seeing a lot of those Bos Indicus cattle, those Brahmin type cattle, because those cattle have really thick hides and the bugs don't bother them as bad. Plus they are really heat tolerant. They don't stress out as much in the hot weather. So you see a lot of those Brahmin type cattle south of North Carolina. And then north of North Carolina, you don't hardly see any Brahmin cattle. And that's because they don't like cold weather. And there's trade-offs, you know, so they're good with bugs and heat, but they grow slower. The meat quality isn't as good. And they they take a lot longer to put that meat on their body. So we see a lot more of what we would like to call British or continental cattle, those Bos Taurus cattle, north of that line. And predominantly the two breeds that we see the most are Angus and Hereford cattle. We used to see a lot of Charolais cattle too, but they are going out of fashion. Those were white cows. Back in the 90s, there was a advertising campaign for something called Certified Angus Beef. And after that, people were able to sell black cattle for more than cattle of other colors because they would get a premium for entering the Certified Angus Beef program. So now all across the United States, you are going to see predominantly Angus influenced cattle because they sell for more money at the market. Now here in New England, we don't take part of the normal supply chain of beef cattle. So most of the United States, so if we look in the southern United States here, in this area, this is predominantly cow-calf operations, so mother cows, and they raise calves. Those calves, once they get weaned from their mother at about 6 months of age, they go to this region of the country and eat grass until they're about 800 pounds or so. And then they go to the feedlots in this portion of the country to be grain fed until they reach slaughter weight. Now, here in Maine, we don't really participate in that supply chain. We are mostly direct sales to the consumer. So, you know, we don't go to the big packing houses out in the Midwest. All of our meat is slaughtered here locally. Most of it is sold locally. And so we see a very eclectic mix of beef cattle because we're not subject to that national marketing schemes. You predominantly see, well, you don't predominantly, you will see a lot of belted Galloway cattle in Maine. Belted Galloway cattle are very pretty. They're also called Oreo cattle because they are black with a white stripe running around their belly. So those are really popular for show animals. And so they command a premium for being a show animal. So they're a good animal to raise here in Maine. You'll see a lot of folks raising Scott Highland cattle. They look like yaks. They're really fuzzy and have horns. You know, they grow very slowly. They're not really the best beef cattle, but they're really pretty to look at. They make good pets, and they're really cold tolerant, so they can survive our weather here. But to answer the question specifically, what is the best cow to raise in Maine for beef? Not one breed is not the answer to this, but you want a small frame, English influenced beef cow. So something around like an Angus or Hereford, or there's a lot of different breeds we could name here, but we want a smaller sized animal, you know, mature weight on the cow, 1,000, maybe on up to 1,100, 1,200 pounds. So we don't have to feed her as much, and she can still raise a decent sized calf. I wish I could say one specific breed fit the region perfectly, but that just wouldn't be truthful. All right, so let's move on to the next question. I don't want to run out of time here. And this question kind of answers another reason that we're talking about beef cattle and tracking animals out on pastures and whatnot is, why can we raise some animals on pastures and some animals we can't? So pigs can eat some grass, but we have to feed them grain. You know, chickens we can put out on grass, but we still have to feed them grain. You know, what makes these ruminants, animals like sheep, goats, cattle, deer, buffalo, able to consume grass and live off of it?
We're up to about 3/4 of the people who are on the line have voted. So we'll leave it open another 5 or 6 seconds, and then we'll share those results. And here you go.
Yep. And all of the above is the correct answer. And I've got one more slide left, and I do a quick tour of the lab. Ruminant animals have a 4-chambered stomach. And inside that stomach lives bugs. And when I say bugs, what I really mean is bacteria, protozoa, and fungi. And so the animals actually live off the byproducts of those bugs. So when we feed a ruminant animal, we're actually feeding the bugs, and then the cow lives off the byproducts of the bugs breaking down that feed. And so one of the things that bacteria can do is digest cellulose. Cellulose is the most abundant form of energy on the planet. It's part of the cell wall of plant cells, and it's basically the only way to break down cellulose so they can use it for their own energy is through this fermentation process that the bacteria go through. There's one animal that can digest cellulose on its own without having to do it through bacteria that live inside their guts, and that's a termite. They actually produce an enzyme called cellulase that breaks down that cellulose. Everything else does it through proxy, through these bacteria, protozoa, and fungi that live inside their guts.
I had no idea about the termites. That was really cool.
I always ask that question when I'm in a group on all my seminars and classes and whatnot. So there's only been a couple times when people got that right.
That's awesome. We are going to learn more about bacteria. I think it's next week with Dr. Sally Malloy and some of her work that she does with the viruses that attack bacteria. So Colt, are you going to take us through your lab quickly? I know some people might have to jump off, so I'm going to launch our evaluation. Ooh.
I am.
And Colt, we're not hearing you at this point.
Can you hear me now? How about now?
We're getting that feedback again.
Okay.
We did test this ahead of time.
Okay, I'm just going to rely on my camera in my office. So if you could switch the screen over to my cell phone. This is my lab, or this is my office inside the lab. We have to have very powerful computers to process all the GPS data, because sometimes we have over millions of lines of data. I just wanted to bring you over here to show you my 4-H quilts. This is my little demonstration sheet. She has her own GPS collar. We've got a demonstration steer here for GPS collars. This is a quilt one of my advisor's wives made me when I left New Mexico. But here's the actual lab. So here's where we keep all of our tools and raw materials. There's the buffalo hide I was telling you about. Here's some batteries for GPS collars. These GPS collars are getting ready for a shipment to go out to Texas. These GPS collars are getting ready to go out to Montana, I believe. Here's my big sewing machine that we sew these things together with. This will sew together inch thick material. The rivet press. This machine actually punches holes into the leather. Drill press. There's our actual GPS units being built there. Inside the fume hood. There's our youth program, GPS cows, where we allow 4-H students to come build their own GPS collar and put it out on livestock and run scientific, like a poster session. And hopefully that worked.
That was really awesome. And we hope to get more participants back up into the lab with you. Hopefully soon we can come back and hang out together and do some more in-person stuff.
Yep, that sounds great.
So I want to thank everybody for coming out. Colt, Dr. Knight, thank you so much. I'm going to go ahead and share my screen quickly here and give those of you who could hang in there till the end just a couple more insight into a couple more things that we've got coming up here. So to learn more about 4-H in Maine, you can visit our website. There are other cool opportunities to learn from home, including more of these science cafes listed at our Learn at Home website. We've got recipes, activities, and more up on those websites. Next week, we are going to have Dr. Sally Malloy join us. Dr. Malloy teaches a really cool class at the University of Maine where students start with a soil sample and see what grows out of it. She's going to talk about bacteriophages, and bacteriophages are viruses that attacks bacteria. So you told us you wanted some more medical science or genetic science type of presentations, so we're going to do that next week. In a couple weeks, we have Dr. Jason Bolton, who is going to take us back to the food science world a little bit, but talk more about innovation and a process called innovation engineering. And that's kind of what Colt did when he needed to develop his GPS collars. He was an innovator, and he saw a problem and he went ahead and worked out a solution to that problem. And Dr. Bolton's going to take us through sort of a process for being innovative. One more thing that I want to point out, and I think Jesse's going to put the actual link to sign up for this into the chat box today, is that a group of 4-Hers have put together this great thinking trap, don't fall into the thinking trap seminar. So how to keep yourself from getting stuck. So if you want to check out what that's all about, you can email Sarah Conant. I've got her email on the screen, or you can check the chat box, and I think the link to sign up for that is going to be in the chat box for you. And anybody, I know we have youth here from multiple states today. I'm really glad you could join us. You guys are also welcome to join this Maine 4-H offering. So if you enjoyed our science cafes, just remember University of Vermont is also offering some virtual science cafes. Theirs are Wednesdays at 3. You can find the link to their science cafe registration page from our website. And I hope everybody stays safe, continue to keep washing your hands all the time. We hope to see you back here next week when we talk more about bacteria, viruses, and the virus called a bacteriophage that attacks bacteria. And thanks so much. I hope you have a wonderful, wonderful rest of your week.